November, remember, no 5, no remember, remember, no remember, no 5. No 5, no remember, no remember, no 5. No 5, remember, no 5. Good morning, mathematicians. It is, of course, the day where we celebrate the animal foxes. And so we sing this poem for them. November, November, 5, no, no, November, no, no, November, 5. The day where we celebrate. And in honor of the fox, the great wily fox, we will do mathematics. Hello, Matthias. Hello, Arad. Hello, everybody. What are we yapping about today? Who knows? Who knows? There are some other things I would like to teach myself. So maybe we'll look at some of that. I have a reason to learn some certain other things. So perhaps we could take a look. Such as operads. You're early today. Or am I late? Let's see. Quick introduction to operad. Quick introduction, gentle introduction. This is gentle and new. Can I explain why Cauchy is equivalent to convergent when it comes to sequences? It is not. It is not. So there you go. It is simply not. Unless you're talking specifically about Cauchy sequences of real numbers, then it is. Am I looking for classical operads or infinity operads? I think just classical operads. I think just classical operads for now. I knew you'd have something to say about it, Arad. I knew you would. Yeah, so in general, in a general metric space, convergent implies Cauchy. But very crucially, the converse does not hold in general. However, what one can do is form... I didn't mean to do that. Hang on. What one can do, given an arbitrary metric space, is form the Cauchy sequence completion of that metric space, where I'm just here to harass you with terrible notation, Leo. That's what gets me going in the morning. Where we define this to be the set of all Cauchy sequences. Of X, of our original space X. So, what does that mean? Well, this thing is called the Cauchy sequence completion because when you upgrade to this metric space, then you can prove. I mean, I guess it takes a little bit of work, but the point is that in here now Cauchy and convergent are equivalent. Yeah. And so what is the real numbers really are the Cauchy sequence completion of the rational numbers. Okay, I haven't explained to you why it's true, I guess. Why is it true? Why is it true? Yeah, I think you need to do some sort of like diagonal argument. Is that basically, because now what do you do if what are the real numbers, right? So suppose you have a sequence of real numbers, right? So xn is some sequence of real numbers. Well, what does that mean? The real number is, by definition, a Cauchy sequence of rational numbers. So xn, each xn is itself equal to a sequence, xn, maybe I'll call this xi. Each xi is now a sequence xj, a Cauchy sequence xj of rational numbers. And now I think the idea is, oh yes, you still have to mod out. Sorry, yes, I should say, right. That's why I put the square braces here. It's sorry, not Cauchy sequences, but equivalence classes of Cauchy sequences. Wait, how do we mod out in general? What do we mod out by in general? Because in the real numbers, it's like if the differences of the sequences go to 0. But what is it in an arbitrary metric space? What's the equivalence relation on the... Oh, I guess maybe that the distances, it's that the sequence of distances go to 0. Well, yeah, but xi, yes, yeah, there you go. Okay, yeah, that's right, yeah. Yeah, so sorry, I should say, yeah, it's modulo this equivalence relation, where so what's the point? So I think the way to do this, so now we need to build a sequence. We need to build a sequence that this sequence will converge to, right? We want to try and prove that this Cauchy sequence converges to some real number x. But again, what is a real number x? It's some Cauchy sequence of rational numbers, right? So now somehow I need to take this whole family of Cauchy sequences of rational numbers and build a single one that we can prove falls into our definition of convergence. So yeah, I mean, that is a good question, Leo. Although, yeah, how does one even go from the Dedekind cut version? Actually, I guess I could see how to do it. But now I think what you want to do is like, I think, I could be misremembering, but I think the strategy is to somehow use like a diagonalization type trick. So this is our first sequence up above, and then here's our second sequence going horizontally. And our third sequence and if I'm not wrong, I think you want to take something, you want to try and do something like this, like build the sequence diagonally. Except I think there's maybe another little trick involved where you start with your first term being x11, but I think you might have to do something a little bit different. You might have to choose x22 further along because you're trying to build it convergent. So probably you're doing something, probably what it is at each step, like once you've chosen x11, you probably want to choose something, so some x2j to make this less than 1 over 2, and then probably once you've chosen that, you want to do something where like x2j, x3k is less than 1 over 3. I'm just guessing here. This is memory / vibes, but I think it's something like this. Something like this. I think this should approximately be your strategy. You define the model of the real numbers. Oh, I see. And then you showed diagonal was the model. You can just straight up take the diagonal, Leo? Okay. Sure, yeah. I was just thinking, okay, it could be, maybe there's something in the proof that it converges to the diagonal that gets messier, but yeah, maybe the diagonal itself just works. Okay, if you use Dedekind cuts, then I guess you got to do this differently. But I guess it's not so bad. I guess, yeah. Maybe it's actually easier because then you can say something about, like, you could argue that if you have Dedekind cuts, then probably it's even easier, right? Because then you could say something, yeah, maybe you can say something like you have the sequence, right? And if it's Cauchy, then so it's a sequence of real numbers. And if it's Cauchy, you could probably argue that it's bounded and non-empty. And then you either take a sup or an inf and then prove that it converges to the sup or the inf. Yeah. Yeah. So those are the strategies, I would say. Okay, I want to look at operads a little bit. What's going on? What's going on here? There are several approaches. Okay. Multi-categories. Planar trees. A multi-category. This is very weird notation if you're going to say it's arbitrary cardinality. But whatever. If it is Cauchy bounded with diameter less than epsilon, so lim sup and lim inf. Oh, yeah. I guess you want the lim inf, or yeah, you want to take like a lim sup or something. Yeah. Set of objects and Hom sets that eat multiple objects. Okay. For each object, what? The set of objects is indexed by ordinals? Huh? The multi-category approach is also sometimes called colored operads. Oh, okay. Good to know. Good to know. We can't call it that in America. That's good. That's good. Okay, so our composition map, AI, AIJ, A, composition, So we have a theta and a theta 1 to theta n to theta composed with theta 1 up to theta n, where theta goes from these n objects. I see, right. Yeah, so it's like we have a1 to an. We get this multi-input map going into here. Of course, we have a composition from these guys. Hey, it's a neural network. Look, guys, I'm doing data science. I am a data science. Nice. Okay, we got a unit. We got associativity. All of our best friends are here to play. What's a simple, ideally funny? I'm a very serious man. I don't have any time for comedy. Example you can use for very basic subsets of sets for basic set theory video. Funny examples of subsets. Yeah, no, you guys are the funny ones. You guys are, saying out of pocket stuff in chat that makes me laugh. Examples of subsets? I don't know. Well, I would list all the subsets of a 2-element set or something. That's helpful. But then maybe you were thinking either Mean Girls or Pokemon, but you don't know Mean Girls well enough. Yeah. Well, stick to your strengths. If you know Pokemon well enough, then make subsets of Pokemon. I don't know. Yeah. Okay. Yeah, what else are the kids? What are the kids watching these days? I don't even know. Pokemon got types and shit, so you could do that for subsets. Yeah, that's true actually. Yeah. That'd work well. In some general formulations, boo, it's a class. Boo, no, we believe in growth and decay hierarchies. In the definition of, K-pop Demon Hunters. Right, I was trying to think. I'm like, anime is big now in general. What's the other? One Piece. The kids are watching One Piece. I think as well. Pokemon is a type theory. Yeah, I agree, Rod. Better suited for types, I would say. In the definition of a multi-category, this can also include the case n equals 0, morphisms with an empty domain. The composition is well defined, even when some of the operations have zero arity. Have arity 0. Understood as morphisms. Okay. Okie dokie. Okie dokie. Artichoke. Growth and decay universes aren't real? Wow. You trying to get banned? Because it sounds to me like you're trying to get banned. The kids are finally watching products. Your favorite math quote of all time is by Erdish, talking about p-adic numbers. You know those things aren't real, right? That's good. I gotta tell that to my research group. That's a good one. It's a very good one. Composite stuff. Okay. Trees. Yeah, what does this have to do with trees? Tell me about trees. Okay, morphisms of multi-category, I can guess. Non-symmetric operad. Okay. A non-symmetric operad, which is to say an operad without symmetry, consists of a family of sets whose elements are abstract n-ary operations of P. Okay. No, you're a tree. I'm an infinite tree. I'm a regular tree. I'm the Bruja Tits building of SL3Q2? No, or is it SL2Q3? So we have a family. PN. Aw, we have a family. We're all together as a family. A family of sets thought of as n-ary operations. And then we have a composition map. I find it strange that we're not calling this, PN, and then this is KN. I think that's a typo. It should be K1 cross here. Are we not? Why did we define multi-categories if we're not using multi-category in the definition here? Get it? Because products, if they exist, are final objects in... A friend explained it yesterday, and now I'm even more bent away from any sort of algebra or topology. I don't, to be honest, coffee handle, I don't get it. But you're bent away from any sort of algebra or topology. Well, that's a shame. That's a shame. You think they're called slice categories or cone categories? Wait, what are slice categories? Look at the next claim after this. Non-symmetric operads as multi-categories. I see. Multi-categories with an object. Okay. Pray tell, good sir, what be the dimension of thine arboreal box? Arboreal box. Coffee handle, what dost thou speak of? These are comma categories. What is a slice category? A slice category is when you take a slice of a category. Isn't that just the category over all objects? You just fix, right? The slice category over X is it's all objects are morphisms into X, and morphisms are triangles. Yeah. Where were we here now? A based category? I've never heard anyone call it a based category, despite the fact that it is indeed based. Comma category. No? Anyone? Okay. So we got some composition maps here. Based spaces would be the slice point over top, for instance. Wait, point over top would be a based? What's your box dimension wise tree? 42. We don't have box here in Math World. Well, it depends. Depends on your metric. Okay, and we've got a unit thing, and we've got some associativity thing. Okay, so the definition of a non-symmetric operad. We have given coincidences with that of multi-category. Let this be multi-category with a single object, which we will simply denote by A. Since the object is unique, every morphism. I see. So Pn is just the Hom sets. I see. Depends on notation. I see. Yeah. I mean, well, but I mean, if you write point/top, this makes me think of, that makes me think it's all, the objects are morphisms out of point. But if you write top/point, this makes me think that the objects are morphisms into point. Which I guess is just the category. So this is not. I would not use this notation for pointed spaces, because I would use this notation for pointed spaces. You feel like based categories are mostly algebraic geometry thing? You mean the terminology, or you mean the concept of them? Algebraic geometry usually uses other types of slice, actually. Yeah. Base change and such, sure. Hello, Castakori. Good morning. You would not call that based? You would not call what based? Yeah, I would not call... Well... I think all math is based. Hell yeah. That's the main reason to come up with terminology, Leo. So I agree with your reasoning. Doing it for the lulz. Doing math purely for the lulz and no other reason. Because it's funny. Okay. So this collection of sets forms exactly the family that defines a non-symmetric operad. The composition law of the multi-category becomes a composition law among here. Okie doke. Okie dokie. Okie dokie. Oh. Real uses based as a synonym for pointed? Okay. Well, hell yeah then. Hell yeah, that's what I say. I see that. I'm a simple man. I see the word based and I say, hell yeah. Just like that, I always clear my throat first, right before saying it. And then I say, hell yeah. That is true. That is true. Maybe you guys already know this, but I did an interview with her a number of years ago. Got to get back to doing interviews. I think I should interview, because I won't be in Calgary much longer. I think I should start interviewing people here at Calgary. Yeah. I think there's a lot of people here at Calgary I should interview. But also, yeah, probably maybe the most famous person is Cockett. Name's been mentioned on stream in other contexts before, so yeah, maybe he'd be interested. But I should definitely start talking to people. You only work in the category top 3 of spaces with a subset, with A subset B subset X. What strange, twisted category is that, Leo? Bizarre. Absolutely bizarre. Was some relative homology thing, but I feel like that would only just be one subset. When does one use top 3? When does that apply? When I set my microphone like down like that, how upsetting is the noise? Is it really terrible? Should I be more mindful of it? But what am I supposed to do? Not pick it up and put it down? This will never happen. Operads. We need an opera about operads. That's what we need. That'll get the kids interested in opera again. It gives you a short exact sequence of pairs, except plus one more space, like you mod out by the relative chains. And your long exact sequence is functorial in top 3. Okay. I'll take your word for it. Okay, I want to see examples. I want to be hit over the head with examples. I want to be beat into death with examples. An operad is enriched if it's got other structures. We do love our enriched structures. From now on, operads will be enriched in VEC. Hell yeah, we love to see it. We do love to see it. Constant operations in an operad. Okay, I want examples. Beat me over the head with examples. There isn't a fundamental insight to it beyond the short exact sequence in pairs, in your opinion, though. Okay. Okay, here we go. We've got some examples. In general, non-symmetric operad can contain n-array operations, including n equals 0. These are constant operations, as they represent operations that require no input but still produce an output. The operations can be thought of as constants generated internally to the operad. Okie dokie. Okay. Your favorite operad is ASS, the associative operad, not to be confused with the atom spectral sequence. Interesting. The associative operad? So, because I know that somehow operads are supposed to be like very general algebraic theories. So, like, are all associative? Is there some like universal property where like all associative things factor through it or something? It's like objects with an associative operation factor through it. Is that the idea? Like, I think, like I want to understand there's this idea, I think, of the Lie operad, and somehow this controls like all Lie algebras. I'd like to understand that. You also need help to prove that lim sup of the sum is less than or equal to the lim sup of the individual things. The sequence A and K are bounded sequences of real numbers, but you're kind of lost on where to start. Let's see. So, limb soup. What do we got to do? Limb soup. So we want to show that limb soup of this is less than or equal to limb soup AK plus limb soup BK. Well, what could we do? Try to deduce similar inequalities for bounded sets. Like inf A plus inf B is less than or equal to inf A plus B, where that's the Minkowski sum. Yeah. I am the universal ass. That's correct. That's correct, Leo. I've got such a dump truck that there's a unique arrow from my dump truck to yours. That's what they say. That's what they say. I'm just repeating what other people have said. I'm just relaying the word on the street as it has been communicated to me. That's what people are saying. I don't know. Yeah. I mean, this should follow. If one can simply prove that this set is if this is an upper bound of this set, right, gang? Yeah, that would maybe be my my first guess at proving this. But is that clear? No, maybe takes a little work. Right. Limb soup of this thing. Let's unpack some definitions here. Limb soup of this thing is the limit as n goes to infinity of the soup of a k plus bk, where k is bigger than n. And mind you, yeah, I think maybe it's even easier because we should have this property, yeah, about the soups. But the Minkowski sum is the Minkowski sum is a little different. Yeah, do we have the additive? We have the additive property of the Minkowski sum, but this is not that. This set is smaller than the Minkowski sum. You're just going to do the Gen 1 starters? Well, I'm old enough that that's the only Pokemon that exists. Actually, no, I think I accept Gen 2. But I'm racist against all other Pokemon, I would say. Gen 3 and above. No, maybe Gen 3 is okay. But, like, I'm a curmudgeon-y old man. You know, I go to the store, I stop in a convenience store, and I look at the Pokemon packs, and I see that there's, what's the newest Pokemon I know? Okay, well, like, I know I have, you know, nieces and nephews. So, like, I know Lucario. I know stuff like that, which I think is already kind of old by now. Yeah. Yeah. But I've definitely seen you used to be a curmudgeon, but now you accept new things. That's good. That's good, Leo. You're emotionally well balanced person. Gen 4, okay. What gen are we on now? Are we on double digits yet, or what? Really, that's only Gen 4? Jesus. Yeah, I guess I can't name any other Pokemon off the top of my head that I think are newer than that. But I've seen them. Oh, lordy, I've seen them. Yeah. But it should, let's see. I mean, probably this will just follow from the subclaim that, like, the soup of this is less than or equal to the soup of the individual things, right? Well, K bigger than N plus soup BK, K bigger than N. Well, that could help, but the problem is, the A plus B is the Minkowski sum, so it's the sum of all pairs. What I would do is I would look at this. I mean, if you can just prove this statement, and now this is easier to prove, right? Because now this is just a soup. So what do you need to do? You need to prove that this thing, that the sum of these two terms, so call this, I don't know, alpha n and beta n. Now you just need to prove that this is an upper bound for this thing. So you just need to prove that for all k bigger than n, ak plus bk is less than or equal to alpha n bn. And this you should be able to do in the same way that we always prove 9. We're on Gen 9. Wow. Gen 10, that's going to be crazy. 1,025. So close to a nice number. Wait, what's a nice number? But yeah, this you say you say sup, not soup. Tips for learning math efficiently? Yeah, don't listen to me. That's my tip. I don't know if I have ever learned math efficiently. I'm like a distracted little math squirrel running around. Yeah. Actually, what does efficiently even mean? I don't know. What does it mean to learn math efficiently? Hello, Daniel. Good morning. Although I may be leaving soon. What time? I mean, I'm basically out of coffee. What time did I start? You generally say don't try to learn math efficiently. It often means you're learning thinly and not learning much. Yeah. That being said, your one tip is to not hesitate too much to move on when you don't understand something. Yeah. Of course, this is a perpetual problem, though. This is like the fundamental problem, right? Of studying mathematics. When do you give up on a question and seek assistance versus continuing the struggle? Did I take longer to learn in undergraduate courses in more than 4? Okay, message gone. Okay. Sometimes it's easier to understand things with more context. Yeah, that's true. Okay. Speaking of leaving, I think maybe we'll leave. I think this is good for today. Did I take longer to learn in undergraduate courses in more than 4 years? I don't totally understand your question. Are you asking if my undergrad took longer than 4 years? Technically, yes, because I went to university for a couple years and then I dropped out. And I didn't do any university. Actually, I took the odd course in that time just for interest's sake. And then when I went back, and then when I took school seriously, it took 4 years. But I had some courses under my belt, so probably you could have called it a 5-year bachelor's. So I don't know if that's what your question is, though. But if that is your question, then yeah, it definitely took longer than 4 years. Am I over 30 then? Yes, I am. Yes, I am. Believe it or not, with this silky, smooth complexion. Probably, can you see? No, you can't see the grays in my hair on this camera or in my beard. They're much more pronounced in real life. I promise I look older in real life. What do we got here? I think you can just use epsilon too. Oh yeah, I guess you. I guess yeah. I guess you could. No, I don't know actually. Yeah, actually, wait. What do you mean by just using epsilon? That's true for a fixed k, and then take limits of both sides. Maybe. Am I over 70? Wow. I gotta leave something up to mystery. Yeah, can't give away all information about me on the internet. Being more specific, you meant it takes undergrads harder to learn math in 4 years with so much rigor early introduced. I'm sorry, Goddard, but I don't understand the way you've phrased that. I don't understand what it is that you're asking exactly. It takes undergraduates harder to learn math in 4 years. Yeah, I don't understand what you're asking. Yeah, I'm not sure I understand. But maybe you can try asking again tomorrow. Because I'm going to take off. I'm going to go get some work done. I'm going to go get some math done. I'm going to do some math. You should do some math. You know what it is. You think it means bye, geriatric math boy? Bye-bye, everyone. Bye-bye.